Okay, so here we have a semi-tricky problem because we have to be really careful with this fact, given that they restrict this domain. Now, they give us this function, and they give us a restricted domain. It's not all of R, right? It's not all of R. It's just from 3, including 3, to positive infinity. And they want us to find the derivative of f inverse at 2. Now, why do they restrict the domain? That's the first thing that we should really be like, wait, what? Why are they restricting the domain? The reason for it is because this is some quadratic. And a quadratic looks like this. And in general, it doesn't have an inverse because it's not 1-to-1. It fails the horizontal line test. There's 2 points here. So there's actually no inverse for a function that's not 1-to-1, or a function that fails the vertical line test. But when they restrict the domain to 3 to infinity, they're only talking about a particular piece of this function, which is from here to here, in which case this yellow part will pass the vertical line test, the horizontal line test. Every single horizontal line will only intersect this curve once. So with that's how we can guarantee that this function has an inverse. That's why we restrict the domain, and then that's how we could even ask this question to begin with. And it's going to play a role when we keep going. Now, to do this, we first want to remember the formula, that the derivative of the inverse function at x is equal to 1 over the derivative of the function with the inverse plugged in at x. Now, using this fact, let's just substitute here. So what takes the role of x in this case? The 2, right? So what do we get? That this is equal to 1 over f prime of f inverse of 2. And I could easily get f prime. That's easy. Let's just get what f prime is. F prime of x is equal to 2x minus 6. And then what I do is I say, well, what is, so that's, I need to plug into this value right here. And I need to sit here and take my time with this. This is a little tricky, but f inverse of 2, right? That's the question mark. But it helps if we say, well, what's f? If I apply f on both sides. And remember, what I'm looking for is question mark. I want to know what this value is. So it's f of what value, right? And that what value is what I want, is going to be, what's f of f inverse? Well, they undo one another, and the 2 just drops out. And now this is sort of the question that will allow me to get question mark. Because it's saying f of what value is 2. And if we look at f, right, so here's f. So I want something, I want to know what to plug in here. So f of what value is 2. And I could just say, let's right, question mark x, whatever, you know. What x value is going to give me 2? And there's something a little strange about this. So if you take your time, and it's typically a nice value. So if I said like, 1, right? 1 won't work. 1 is going to give me 1 minus 6 is negative 5 plus 10 is 5. It doesn't equal 2. So question mark isn't 1, right? So question mark isn't 1. But maybe it's 2, right? And what's wrong with all of these values? Well, let's try 2 and let's see. So 2. So f of 2. Does that give me 2? 2 squared is 4 minus 12 plus 10. 4 minus 12 is negative 8 plus 10 is 2. So 2 is my answer. And that would be a mistake. And I made this mistake myself because I forgot that the domain does not include 2. So I can't plug in anything less than 3. That's going to get me 2, right? F inverse of 2, right, equals some value. If you're looking for this value, it's 2. F of what value is 2? you can't plug in 2 here because the domain does not include 2. You'd have to start with 3, and then 4, and then 5 or 6 or whatever, and you have to find the value, and there's no other way to do it. You gotta sit here and just test it. But they always make these problems so it's close, it's not like you have to go and check every single real number, and it's always a whole number. It's a nice value. So you sit there and you check. So it's gonna be, let's say I said 3. So 3 squared is 9, minus 18 is negative 9, plus 10 is 1, not 2. Okay, let's try 4. 4 squared is 16, minus 24, plus 10. 16 minus 24 is negative 8, plus 10 is 2, and f of 4 is 2. And this is the 4, this is the value you really want, because that's in the domain of this function. So that means that when I apply f inverse to this, I get what I wanted, because these two undo each other again, and I get 4 is equal to f inverse of 2, and then that's exactly what I want to plug into here, right? F inverse of 2 is right there, but instead of writing that, now I can write it as 4, and then I have f prime, so I could finish this by just saying this is equal to 1 over f prime of 4, and then f prime of 4, I'll take my time, f prime of 4 is equal to 2 times 4 is 8, minus 6 is 2. So then I get 1 over 2, and then that is my final answer, because I found f prime of 4 to being 2.